To enable us to move our player node around, we will need some new things in our GameViewController class. We will need gestures to control the movement, where we will implement swipe gestures, and we will need actions as scene-actions to actually perform and animate the movement. For both of them, we will define custom methods. To set them up and initialize them, I will add them right below the setupLight method. And one will be called setupGestures, and the other will be called setupActions, both without any parameters. We will begin with our setupGestures method, since it doesn't require any new properties in our class, and we can just add everything we need locally in the method. I want to add 3 different swipe gestures to my view for swiping up, left, and right. Let's begin with a constant called swipe up, which I will initialize as a UI swipe gesture recognizer with the initializer, with the target and action parameters. For the target, I'll say self, so the GameViewController class, and the action will be a method that should later handle the swipe. And since we don't have this method yet, we will implement it in a second. So I can already write selector and then the handle swipe method for the action. To not get any errors, I will obviously have to implement the method for the GameViewController class. And I want to extract this in an extension of the GameViewController class, so right below the class itself. So I will write extension and GameViewController. This extension will contain any gesture handlers we need. For now, we will only have one handler method, but writing it in its own extension will keep our main class a little less cluttered. I can then add the handler method, and since I specified it as a selector in the recognizer, I will have to prefix it with add Objective-C. Other than that, I can define it just like any other method. So func and then handle swipe for its name. It will have one parameter called sender of type UI swipe gesture recognizer, since we will need to check what kind of swipe occurred, meaning up, left, or right, since we will use this method for all of our swipe gesture recognizers. Now that we've added it, I can continue in the setupGestures method, where I want to set one property in my swipe up constant, which is swipe up dot direction, which I will set to dot up to specify that this gesture recognizer should handle swipes in this particular direction. Now all that's left to do is adding the recognizer to my scene view, and we don't have to do anything else than we would have to do when adding it to an ordinary UI view. So all I need to do is sceneview.addGestureRecognizer and then pass swipe up to add the recognizer. We will now have to do pretty much the same exact thing for the left and right swipe gesture recognizers. So you could skip ahead a little in this video if this is too repetitive for you. I'll now just write the 6 missing lines here. Starting with the constant called swipe right, which I will set to an UI swipe gesture recognizer with the target self, and the selector handle swipe. This time I will obviously set swipe right direction to dot right. And finally with sceneview.addGestureRecognizer and swipe right added to my view. Finally, I'll add another constant called swipe left as UI gesture recognizer with the target self and the action handle swipe. Swipe left dot direction will be set to dot left, and sceneview@GestureRecognizer and swipe left adds our last gesture recognizer to the view. And that's all we need to do for our setupGestures method. We should now call our method, which we will again do from our viewDidLoad method right below setupLight with setupGestures. Since we are already here, let's also call our setupActions method right below, which is what we are going to implement next. To do that, we will need 3 new properties, which I will add right below lane count. And those are just 3 actions we will use on our player, simply to be able to move him. Our chicken should be able to jump forward, to the left, and to the right. Therefore, I will begin with a variable called jump forward action as an optional scene action. Next is a variable called jump right action as an optional scene action. And finally, a variable called jump left action, also as an optional scene action. We can then scroll down to our setup actions method, where we will define and initialize our actions. It won't be as easy as just assigning a single action to the properties, but we will create some kind of compound actions made up from other smaller actions. If we, for example, jump forward, I want to move my player node in this direction, but I also want it to jump. So we should probably move it up and down too, while making sure that we're always facing the right direction, so the one we're jumping in. All of that should ideally be executed simultaneously, so simply to get a smooth jumping animation. We'll begin by building our up and down motion, starting with the constant move up action, which I will initialize as a scene action.moveBy. And I want to choose the initializer with the X, Y, and Z, as well as the duration parameters. This action should move my node up so that we can move it down later again. This means we will only need a movement in the Y direction. So X can be 0, Y will be set to 1.0, and Z will be 0 as well. The duration is going to be 0.1, so really short. We will then have to bring our node back to the ground, which we will do in another action called move down action. And it will be a scene action.moveBy, where I will now just reverse my prior movement. So I'll say negative 1.0 for Y, X and Z will be 0, and the duration will again be 0.1. I do want to specify the timing mode for my 2 actions to make my jump look more physically accurate. Because if I would just run it linearly, it would look pretty unnatural and not like an actual jump taking place in a world where there's gravity. For the move up action, I will make sure that it slows down towards the top. So I'm going to write move up action .timing mode and set it to .ease out, so that our player jumps quickly off the ground and then slows down until he reaches the highest point in his jump. For the move down action, we'll do the exact opposite by writing move down action .timing mode and setting it to .ease in, which will slowly begin the descent and accelerate it towards the end until the player is on the ground again, which physically makes sense. I now want to combine these 2 actions in a sequence, which will run them one after the other. So I'll create a constant called jump action as a scene action.sequence, which I will pass the array with move up action and move down action to, in this particular order, to make sure that we start by jumping up and then go down again and not the other way around. This concludes the actual jump, but we now need to move the player node in a certain direction, and that's what we're going to do next. So I'll begin with a constant called move forward action, which will be a scene action.moveBy, and if I want to move forward in my scene, I will have to move to a lower value on the z-axis. X and Y will therefore be 0, and for Z I will say negative 1.0 to jump 1 tile forward from our perspective. The duration will in this case be 0.2, and some of you may already have guessed that this makes sense based on the fact that our jumping sequence takes 0.2 seconds in total. So what we just implemented with the up and down motion. And since our complete jump animation takes 0.2 seconds, it only makes sense that both of these move up and move down actions take exactly half that. Okay, just like that, I will also add a move right action constant as a scene action.moveBy. And to move right, I will of course have to move to a bigger value on the x-axis. So I'll say 1.0 for x and 0 for the other values. Duration will again be 0.2. Our move left action will also be a scene action.moveBy, in which case we'll of course say negative 1.0 for x to move to the left, and 0 for the other two values, with the duration being 0.2 again. This concludes our 3 actions for movement in the appropriate direction. And before we can start combining the actions, I will also add 3 more, to always make sure our player node faces the right direction, so meaning the one that the player is heading in. We did see when we last ran the app that our chicken was facing backwards, and if we now make sure that our jump will always rotate the chicken, this should be fixed. Our first constant will be called turn forward action, and it will be a scene action.rotate2, and I'll choose this one with the x, y, and z values, as well as duration and uses shortest unit arc. I will then have to specify my rotation for the x, y, and z axis, a duration for my action, and the uses shortest unit arc bool, which when set to true makes sure the chicken uses the shortest possible rotation to get to the desired orientation, which makes sense. The only axis that we want to rotate around is the y-axis, which will turn our chicken to the left or to the right. We don't want to tilt our chicken or make it face the ground, so we can say 0 for x, and since we do know that per default our chicken faces backwards to jump forward, I'll just have to rotate it by 180 degrees. So y will be 2 radians with an angle of 180. Z will be 0, the duration will of course be 0.2, and shortest unit arc will be set to true. Just like that, we will need turn right and turn left actions, starting with turn right, which I will set to scene action.rotate2, x and z will again be 0, duration will be 0.2, and uses shortest unit arc will be true. To rotate our chicken to the right, we'll have to set the y value to negative 90 degrees. So I'll just do 2 radians with the angle negative 90. The turn left action will be exactly the opposite, so I'll set it to a scene action.rotate2 with x being 0, y will be 2 radians 90, and z will be 0. Duration will be 0.2, and shortest unit arc will be set to true. We now have a jump animation in the jump action, a movement in the appropriate direction in the move actions, and turn actions that turn our player node to face the correct way. I can now take all of these actions and combine them in my property actions, which I've defined at the top of my class. So, jump forward, jump right, and jump left action. Let's start with jump forward action, which I will initialize as a scene action.group, and contrary to the sequence action, the action array passed to this will all be executed simultaneously. To jump forward, I will pass the actions turn forward action, jump action, and move forward action to my array. Exactly the same will be done to initialize the other 2 actions, with jump right action being initialized as a scene action.group with the actions turn right action, jump action, and move right action. And then finally, jump left action initialized as a scene action.group with turn left action, jump action, and move left action, so that our 3 property actions each contain the complete and combined jump animations. I can then use these properties, jump forward, jump right, and jump left, in my handle swipe method to react accordingly to the different swipes our user performs. To differentiate between them, I will start with a switch statement in the handle swipe method. Since we have a parameter sender of type UI swipe gesture recognizer, I can just say switch sender.direction and then check for my defined swipe directions. Let's start with the case UI swipe gesture recognizer direction.up, which would be the case when our user swiped up. And for this case, we will add a break statement for now. We'll come back to it in a moment. But first, we'll add the other two cases, which we'll handle directly here. The swipe up will be a little different, since in this case we'll later need to do a little more than just move the player node. But let's continue with the case UI swipe gesture recognizer direction.right, where I can directly implement what I want to do. It is important to note, however, that we don't want to be able to jump off our map or off our lanes. So we will need to check whether we are at the rightmost edge of our map, and only if it isn't the case, allow a jump in this direction. Since our lanes are 21 wide and our player starts right in the middle, I obviously want to check if player node.position.x is less than 10, which would position our player in a valid area to our map. And only in this case, we want to run our jump right action by writing if let action is jump right action, since this property is optional, and if we do have a valid value, we can write player node.run action and pass the action, which will make our chicken jump to the right. Pretty similar to this, we'll then add case UI swipe gesture recognizer direction.left, where we now need to check if our player node is still on the map and not left of our map, which we can do by checking if player node.position.x is bigger than -10, in which case, again, we'll try to initialize our action with if let action is jump left action, and then player node.run action and action to run the action. For the default case of our switch, I will add a break statement, since we only want to handle swipes up, right or left. For the case up, I will now add a custom method in my GameViewController class, which will be called jump forward with no parameters. And I just want to call this method in my switch for the case up. Inside of the jump forward method, I will not really do anything differently than for the jump left and right cases. I just check if let action is jump forward action, in which case I will run the action on my player node, simply to perform a jump forward. Later on, we will add some more code to this method every time our player jumps forward to make sure our game adapts, and this is why we have wrapped this in its own method. We should now be able to test this, so let's run the app and see if we can jump. To test it, I will now use a real device, since it will be pretty laggy on a simulator. Our app started, and as soon as I swipe, we can see our chicken is jumping beautifully, and the animation looks pretty well. If I jump to the left or to the right though, I can see that the orientation is not quite right, and we should probably fix that. We'll fix it in a second, and we should also maybe take care of the problem that I currently am able to jump just out of the screen, since our camera doesn't yet follow our player node. But this is what we're going to look at next.